Good morning students. I welcome you in today's session of physics. Today we will study about spherical mirror. This is your chapter number 14 of optics. So we will talk about first spherical mirror. A spherical mirror is a part of hollow sphere. I hope you know what is a sphere, whose one side is silver and coated with red oxide and the other side is a reflecting surface. A spherical mirror are of two types. One is your concave and the other one is convex. Here you can see in the figure number 1, the two mirrors are given. The first one is your concave and the second one is your convex mirror. So first we study about the concave mirror. A concave mirror is one whose reflecting surface is toward the center of which the mirror is a part. What does it mean? It means that the reflecting surface of a concave mirror is toward the center of the sphere. You can see that it is just the part of the sphere. But if we draw a hypothetical sphere like this, so it is a complete form of sphere where C is the center of the sphere. So this mirror is a part of sphere. Same thing, it also happened with the convex mirror, but in convex mirror is a mirror whose reflecting surface is away from the center of the mirror or sphere of which the mirror is a part. This is also a part of the sphere, but its reflecting surface is away from the, you can see it is written here. Now there are few definitions regarding spherical mirrors. So first we talk about pole. What is the pole of a mirror? The central point of the reflecting surface of a mirror is called the pole of the mirror. The central point mirror is known as pole. In the above figure you can see that A and B. P here, this is the concave mirror. So this is the pole, the central point. This is the central point of the mirror. Clear? So this is the pole of concave mirror, and similarly this is the central point of convex. So here it is a pole of convex mirror. Now we will move to center of curvature. The center of the sphere of which the mirror forms a part is called the center of curvature of the mirror. In figure F, first A and B, C is the center of curvature of each mirror. You can see here, this is center of curvature of concave and this is the center of curvature of convex mirror. Or you can also say, if you draw a whole sphere, this is the center of a sphere. I hope it is clear. Now we will move to radius of curvature. The radius of the sphere of which the mirror forms a part is called the radius of curvature of the mirror. In the above figure, you can see the radius PC is the radius of curvature. Here, this is the distance from C to the pole PC in concave, and same thing in P to C in convex. This is your radius of curvature. The radius PC is the radius of curvature of each mirror. It is equal to the distance of the center of curvature from the pole of the mirror. Now, principal axis. The straight line joining the pole and the center of curvature of the mirror and extended on both sides is called the principal axis of the mirror. So what is the principal axis? You can see here in the above figure, the distance from pole to the center of curvature, it is your radius of curvature also. But what is the difference between principal axis and the radius of curvature? If we extend in both the direction from C to P and here also, so it is the total distance is known as principal axis. This is your principal axis. Now we will talk about what is aperture. So the diameter of the periphery. What is periphery? Periphery means you can see the curved path which is your M1 to M2 in concave, and same thing also in convex mirror. So this is the periphery of the sphere, or you can say mirror. So the periphery of the mirror is called the aperture of the mirror. In the above figure, the straight line M1, M2 is the aperture of the mirror. As I told you, this is your aperture here. Clear? And same thing also in here from M1 to M2. So the straight line joining the M1 and M2 is known as your aperture. Now we will talk about principal focus. The point on the principal axis at which light ray parallel to the principal axis. After reflection from the mirror, I hope you know the reflection and refraction. You already studied in the previous classes. So, the point on the principal axis at which light ray parallel to the principal axis after reflection from the mirror actually meet or appear to come from is called the principal focus of this mirror. Here you can see in the figure number 2, this is your principal focus. This is the focus for concave and this is the focus for convex mirror. Clear? And what is does it mean? It is written here, it actually meet or appear to come, because if you see in figure 1 or A concave mirror, all the incident ray are meeting at the focus F, which is your principal focus. But if you see convex mirror, the incident rays looks like it comes out or appear to come from the focus here. This is the principal focus of convex mirror. So, in case of concave mirror, the reflected ray actually meet at the focus. What the property of concave mirror? If the incident rays are incident on the concave mirror, so concave mirror converges all the incident ray at a particular point, and that point is known as your focus. Here you can see this is your focus of the concave mirror. Now, same thing here, if you see the incident rays on the convex mirror appears to come from the focus. Clear? So, these rays looks like they are coming from the focus, and the property of the convex mirror is to diverge the incident rays. You can see here. In case of concave mirror, the reflected ray actually meets at the focus, while in case of convex mirror, the reflected ray appear to come from the focus. I hope you understand. Thus, the focus of a concave mirror is real and lie in front of the mirror. You can see easily this is the focus of concave mirror. It is a real and lie in front of the mirror, while in case of convex mirror, the focus is virtual and lies behind the mirror. This is the focus of convex mirror. Now we talk about focal length. The distance of the principal focus from the pole of the mirror is called the focal length. Means the distance between the focus and the pole of the mirror. This is your distance in concave and this is the distance in convex. So, the distance between focus and pole of the mirror is known as your focal length. I hope it is clear. Now, we talk about focal plane. So, the plane perpendicular to the principal axis and passing through the principal focus of the mirror is called the focal plane of the mirror. Here you can see this is your focal plane passing through the principal focus and perpendicular, this plane is perpendicular to the mirror also. For a spherical mirror, the laws of reflection hold in the same manner as for a plane mirror. What does it mean? Means the laws which you are using for the plane mirror are same applicable on the spherical mirror also. A line drawn from the center of curvature to any point on the mirror is normal to the mirror at that point. So, if you draw a line from the center of curvature, here you can see if we draw a line from the center of curvature, it is always normal to the mirror. Either it is in the case of concave or in case of convex mirror. Now, we are going to prove the relation between focal length, which is your f, radius of curvature, which is your r, of a spherical mirror. For a spherical mirror of aperture small compared to its radius, means the aperture of the mirror is small as compared to the radius of curvature. So, then the focal length of the mirror is how much? Is 1/2 of the radius of curvature, means f is equals to 1/2 of r. This relation can be proved for concave and convex mirror. So, this relation we have to prove for concave and separately. So, first we take for concave mirror. As you can see, this is your the figure of concave. Clear? Let us consider a small aperture concave mirror whose aperture is m1 to m2. You can see here in figure 3, whose pole is P. This is the pole and F is focus and center of curvature is C. These are the things of, this is your center of curvature. A light ray OA, here you can see this is the light ray which is parallel to the principal axis, strike the mirror at where, which point? At A, and is reflected along AB, and after striking the mirror this light reflected in which direction? AB, here you can see reflected in this direction, passing through which point? Passing through the focus. The line from the center of curvature C to the point A, you can see here, this is the line, this one. So the line from the center of curvature C to the point A, this point, is normal to the mirror at A. So this line is normal at A, therefore angle OAC is the incidence angle. I hope you know what is incidence angle. The angle which is formed by the incident ray is known as incidence angle, and the angle which formed by the reflected ray is known as reflected angle. So angle OAC is the angle of incidence I, and angle CAF, you can see here, is the angle of reflection, which is your R. I hope you are able to see, this is your angle of reflection. Now angle OAC is equals to angle CAF. Why? Because they form a pair of alternate angles. So angle OAC is equals to angle ACF, that is your I. Clear? Therefore angle ACF is equals to angle CAF. Fine. From this point now we take here AF is equals to how much? FC. This is the simple geometry you have already studied in class 10. Since the aperture of the mirror is small, so the point A is very near to point P. What does trying to say? If we take the distance from A to P is very small, or we consider the point A is very near to point P, so we consider it as AF is equals to FP, means the distance between the two is almost equal. So from this relation, here you can see that this here, we take in place of AF we put PF. So PF is equals to how much? FC, and we already study that FC is equals to, what is the FC? FC is the distance of center of curvature to the principal focus. So we take here FC is equals to half of PC. Clear? PC is your radius of curvature. Clear? So PF is equals to how much? Is your focal length, and PC is your radius of curvature. So we put the value of PF equals to F and PC is equals to R in this equation, and we get what? Here we get this relation, F is equals to R by 2. I hope you understand it. This is the thing we have to prove for the concave mirror. Now we will move to same thing we have to prove for the convex mirror also. So we are moving for convex mirror. So this is your convex mirror. You can see here, this is the figure of convex mirror. In convex mirror, let P be the pole, clear, F the focus, and C the center of curvature of a small aperture convex mirror. Fine. M1 and M2 you can see in figure 4 is your aperture M1 and M2. A light ray with OA parallel to the principal axis, here you can see easily, this is a light ray OA which is parallel to the principal axis, strike the mirror at which point? At point A and is reflected along AB, and after striking the mirror, it's reflected in which direction? From at point A, after reflection it goes in AB direction. That AB such that on producing back, the reflected ray AB appears to come from the focus F. So if we produce these rays backward direction, then it appears to come, it looks like it's coming from the principal focus. This is your principal focus of convex mirror, you can see here. The line drawn from the center of curvature, which is your C, to the point A and produced to N, here you can see easily in figure 4, and is normal to the mirror A. Therefore, angle OAN is your incidence angle and angle NAB is your reflected angle. Clear? So now, as we have already proved for the concave mirror, same thing we are going to prove in the convex mirror. So OAN is your incidence angle and angle NAB is your reflected angle. So by the law of reflection, angle I equals to angle R. Now angle OAN and angle FCA is equals to I, which are the form of corresponding angles. I hope you know very well what are corresponding angles, vertically opposite angles. So I am not going to tell you about this because these are the mathematical terms. And angle NAB is equals to angle CAF equals to how much? R. NAB equals to angle CAF. They are the vertically opposite angles. So from this relation, we considered it as angle FCA is equals to how much? Angle CAF, or we can write it if F is equals to how much? FC. Now since the aperture of the mirror is very small, so the point is A is very near to point P. Clear? Same thing we have already covered in concave mirror and now in this convex mirror. So we can put here AF is equals to PF, this we can easily take it. Thus PF equals to how much? FC equals to half PC, this. Now PF is your focal length and PC is your radius of curvature of the mirror. So we put the value of all these in this equation here and we get what? F is equals to R by 2. This is the relation we finally get here and this is the thing we have to prove. I hope you understand what I am trying to say. So that's all for the today's class, students.